All right, guys, welcome to Parametrics. This is going to be the last amount of notes we do for Unit 9. For the first example, it says to sketch the curve given by each pair of parametric equations over the given interval. X is equal to t squared plus 1, and y is equal to t over 2 plus 4. And t has to be greater than or equal to -3 and less than or equal to 3. So the easiest thing to do is to create a chart. We have a really restricted amount for t, so that's going to help us quite a bit. So we're going to find the x and y given each t. We've got -3 to +3. All right, so we're going to plug in the t for each x and find each x, and then plug in the same t for each and find each y. And then those will be corresponding coordinates, and we'll just plug them in. All right, so when t is -3, I'm looking strictly at the x equals t squared plus 1 equation. We do -3 squared, which is 9 plus 1 is 10. -2 squared is 4 plus 1 is 5. 0 squared plus 1. 1 squared plus 1 is 2. 0 squared plus 1 is 1. 1 squared plus 1 is 2. 2 squared is 4 plus 1 is 5. And 3 squared is 9 plus 1, which is 10. All right, and then we're going to find the y's. Okay, so we have -3 over 2, which is -1/2, plus 4 is a positive 2.5. -2 over 1 is, -2 over 2 is -1, plus 4 is 3. -1/2 plus 4 is 3.5. 0 over 2 is 0 plus 4, which is 4. 1 over 2 is 4.5. 2 over 2 is 1 plus 4, which is 5. And then 3 over 2, which is 1.5 plus 4, which is 5.5. All right, so we are going to plot the x and y, the corresponding x and y for each t, and go from there. So let's start with 10, 2.5, 5, 3, 2, 3.5, 1, 4, 2, 4.5, 5, 5, and then we have 10, 5.5. So, starting at where t is -3, we're going to go all the way here and curve. And this kind of just shows you the path that it takes. So t tracks the path of the object. All right, and this is what it looks like when it's graphed. Let's move on to example 2. Example 3, we're going to use the same type of rules here. We're going to solve for t and plug into other equation. And so how you're going to do that, this is what you're going to do on several different types of parametric problems. It says to write in rectangular form. Now, rectangular form, and I'm going to put that here just to make sure we know, means that it only has x and y variables. That means there's no t. So we have to get rid of t. We cannot have t in the equation for it to be rectangular form, and it needs to be combined. So the first thing we will do is change the x equation to equal t. So we're going to move everything over in the x equation to where it's t equals. And then we will plug in value of t in y equation. Okay, and that will look like this. So the first thing we have to do is change the x equation to where it equals t. So that means we would divide by -3, and that means t is equal to x over -3. All right, we're going to need that. We are going to replace t in the y equation with x over -3. So we have y is equal to t squared minus 4, y is equal to x over -3 squared minus 4, which is going to be y is equal to x squared over -3 squared, which is 9, minus 4. All right, and that is our rectangular form. Okay, it kind of looks like a y equals mx plus b, or kind of like our conics that we were working with in the last notes. All right, so we're going to do the exact same thing again here, right, in rectangular form. So we have to take the x equation and get t by itself. So we're going to square both sides. So we have x squared is equal to t plus 1. Subtract 1. So we have x squared minus 1 is equal to t. Okay, we will replace t with x squared minus 1. So we have y is equal to 1 over 2t, which is going to be y is equal to 1 over 2x squared minus 1. And just to take it that step further and distribute that 2, we're going to have y is equal to 1 over 2x squared minus 2. All right, and that is going to be our rectangular form. Are there any restrictions on the domain? Is there any value of x that we cannot use? So one thing you'll have to pay attention to is if this is a square rooted x, that means that x cannot be negative. X will have to be greater than or equal to 0. That's the first part of the domain. All right, the second part is, and we've done this before in further back units, take the denominator and set it equal to 0, because whatever we get, we cannot use for a value of x because it will make the denominator 0, and if it's 1 over 0, that's undefined, so we don't want our graph to be undefined. So then we have 2x squared is equal to 2, divide by 2. X squared is equal to 1. That means x is equal to plus or minus 1. So x cannot equal positive or negative 1. All right, and those are the restrictions on the domain. Okay, let's flip to our other side. So we have right in rectangular form. So we're going to do the exact same thing again, except now we're using cosine and sine instead of t. So we have to recall some information from our trig identity sheet. One is that sine squared theta plus cosine squared theta is equal to 1, and secant squared theta minus tangent squared theta is equal to 1. All right, so these are, we're going to take x and we're going to set it equal to cosine, and we're going to take y and also set it equal to sine, so then replace it with this equation. All right, so we have x is equal to 2 cosine theta, so we divide by 2. That means cosine theta is equal to x over 2. Okay, that's going to be what we use there. And then we have y is equal to 4 sine theta minus 3. We're going to add that 3. Y plus 3 is equal to 4 sine theta. Divide by 4. And our sine theta is equal to y plus 3 over 4. Okay, so since we have that equation, cosine squared theta plus sine squared theta is equal to 1, we will then replace it with x over 2 squared plus y plus 3 over 4 squared is equal to 1. And this looks a lot like our conics, and we're going to actually find out what conic shape is represented as well. All right, so now just simplify this. I'm going to distribute that squared to the top and the bottom of each. So we have x squared over 4 plus, we're going to leave that top as y plus 3 squared over 16 is equal to 1. All right, because we are adding together and they're both squared, this is going to be an ellipse. And just for extra info, the center is at 0, -3. All right, I'm going to do example 5 on this one. If you want to pause and try this one, you're going to end up using this equation here rather than the sine squared plus cosine. You'll be plugging that in. We're going to work example 6 on a separate video. All right, so let's go ahead and set x equal to secant and y equal to tangent. So we have 2 secant theta plus 1. So we have x minus 1 is equal to 2 secant theta. We're going to divide by 2. That means that secant theta is equal to x minus 1 over 2. All right, then we have y is equal to 3 tangent theta. We're going to divide by 3. That means tangent theta is equal to y over 3. Okay, now we will use this equation, secant squared theta minus tangent squared theta is equal to 1, and we will plug in the following that we found. So we have x minus 1 over 2 squared minus y over 3 squared is equal to 1. And again, we'll leave the top as x minus 1 squared over 4 minus y squared over 9. And this is equal to 1. And because we are subtracting, that means that this is a hyperbola. And the center is at 1, 0. All right, we are going to work number 6 on a separate video because it's long and there's a lot of work to go with it, okay?